Question for you. So what'd you learn tonight? What did you learn about the process?
Hard to find it.
It's very... Okay, one at a time. One at a time. Very hard to find data. Okay, find good data. Got it? What else? What's another thing? Yeah, Guyan.
For things for like colleges, it's like not too bad to find things from 2009, but finding things that are going back in time.
Historical collegiate data is hard to find.
Yeah.
Collegiate data regarding what? Like
Admissions or
is very hard to find. Why do you think that is?
I think they didn't spread it
One
out.
at a time. Yeah, we'll go. What do you think?
I think they don't want to post the fact that their admission rates are slowly going down.
Well, there's probably a lot of reasons like that. I mean, they want to control the information for that purpose and maybe whatever. They want to control the message, right? You're totally right.
You're gonna get in.
Yeah. No. I was the first person in my entire senior class to get rejected from any college. It was amazing. I love that feeling. Everybody else was like, yeah, I got deferred. And I was like, nope. Okay, moving on. Baldwin. Hard, yeah. So just hard to find the scope you want, right? What else? What else? What about the process? What did you learn about the process of modeling? What did you learn about the process of modeling? Not specific to the topic, but the overall process of modeling. What did you learn? Anything else? What? Patience is a virtue. Absolutely. What else? Anything else? It helps to have even semi-functional internet connectivity.
I think
Yep. What else?
it's hard to model more than one information. Like if you need to compare, set like the Ivy League, there's like
Comparing data sets can be tough. Yes.
make every single
Comparative
one.
analysis. Yep. Anything else? Okay. What did you learn topically? So what did you learn about your topic? Someone give me something specific. Macy.
That the amount of people.
What's your topic?
Admission rates to Northwestern.
Admission rates to Northwestern. Yep.
That the amount of applicants is going up, and they're even accepting more people than they did in previous years, but the admission rate is still declining.
But the overall percentage of people admitted is still going down. That's a very good observation. Yeah, absolutely. Okay, something specific. Hanley, yep. What's your topic?
Mine is the absence.
Okay. Admissions to Ivy. Yep.
Absence.
Yep.
Okay.
Mm-hmm.
More people applied, but less people got admitted.
Yep. So you looked at all broader than just one, and you saw that hold true.
In the total, like I count the total number.
A smaller percentage get in.
Yeah.
Okay. Another topic. Something you learned. Yeah. What did you learn? What's your topic?
The internet users.
So this is internet users compared to Facebook. Yep. Yep.
And I saw that they're increasing at the same rate because the graphs look almost the same.
Okay. Anything else about that topic? What else? Yeah. What did you find out?
I found a different result is that the percentage of Facebook user
Yep.
is growing, and now
The percentage of what? You're talking about the percentage of Facebook to
Facebook
internet, you mean? Is growing. So they're both growing very quickly.
Yeah, and now 2010.
Yep.
The percentage is almost 27%.
So 27% of internet users have a Facebook account.
Yes.
Wow.
Something very interesting happened on the
Growing.
and it's still growing. Something very interesting happened on the internet-wise this last week. Anybody know what it was? It's kind of geeky and dorky, but really important actually. We ran out of IP addresses this week.
Oh yeah.
Yeah, this week. Every device that's connected to the internet has a unique number associated with it. We ran out of numbers.
So what do they do?
We can talk a lot about this. It's a very complicated process because one of the great things about the internet is no one person or one entity runs it, but one very horrible thing about the internet is no one person or one entity runs it. It's very difficult to change things system-wide, which is one thing that's the greatest thing about the internet. Moving on. You can read about that on your own. Okay, other topics. What'd you learn? Other topics. Anything else? Nothing else? You learn anything? What'd you learn about wage gap?
Well, I found that
What was your prediction?
they would be the same in
Predict
2023.
Equal wages in what?
2023.
Okay. What else?
But, the men's income was very scattered.
So what does that mean about your prediction?
The line that I found,
Yeah.
there probably isn't very.
So not so confident in your model. Got it. Any other what else? Anybody else notice anything else about their data? Anything else? Any conclusions at all? Anything? Okay, please put everything away except the pencil. No calculators. Take out your calculator. There's the data set I got for average temperatures in St. Johnsbury. Let's take a look at the mean temperature. Let's take a look at the mean temperature. I want you to come up with an equation that models that data. By yourself, without talking, please come up with an equation that models that data. Please round to 2 decimal places. Let's round to 2 decimal places. Rounding to, let's say 3 because I like 3. Sorry, I'll change my mind on the fly. Sorry. Round to 3 decimal places. Come up with an equation that models that data by yourself without talking and asking any questions whatsoever. Please use the mean temperature. So what I'd like you to do, so when you did your graph, should have ended up with something like this. Using the function that you came up with, using the model you came up with, what will the temperature be, the average temperature be in January of 2014? Using your model, what will the average temperature be in January of 2014, using your model?
Can we go back to the data?
You didn't put it into your calculator?
I thought what year is it?
Oh, what year is it? Let's say this was average data for this year. Let's say it was 2010. That's a good question. Assume it's from 2010. Using your function, the one you came up with, tell me what the temperature is going to be in January of 2014. Many of you should have a graph that looks something like that, right?
Yep.
Each of your models should look like that.
Wow.
Okay, did anybody have a prediction for me? What's the January temperature in 2014? Yeah, what do you think? 546. Anybody else? Other predictions, yeah.
I got minus 10,000.
10,000 what?
563.
63, okay. Any other guesses, no matter how weird they are? Yeah, Henley. He's counting decimals on his calculator.
100, 100,000.
Yep.
Can I just say the number out? 113661.
113661. 113,000 degrees. Yeah, it's really hot. So, you'll notice something. Do any of these seem logical? Well, first of all, let's look at the really big ones. Do the really big ones seem logical or even possible? Like, can you get to negative 10,000 degrees Fahrenheit? No, you can't. What about 113,000? What about, okay, now what's wrong with 55? 55, average temperature of 55 degrees Fahrenheit in January? Seems a tad warm. Tad warm. So here's the thing. Your model might be accurate for the given data set, but you must remember reality. So here's the thing. Any of these models except for one is going to go off and have its end behavior go infinitely down or infinitely up. Every model but one. What model do we want to look at, Baldwin? Yeah, we want to look at Baldwin's model. That's right. Which one was that? Sine regression. That's correct. We're looking at trig models. When do you look at things that are... why would you want to use a trig model in this case? Yes. It's an oscillating... How do you spell oscillate? It goes up, it goes down, it goes up, it goes down. It oscillates. Sine wave, cosine wave. So the standard regression model is with a sine wave. So here's my model. Does that look like similar to yours? Does that look similar to yours? If I go into window, and I'm going to extend the x to, I don't know, 50, look what happens. It oscillates. So if I wanted January of 214, January of 214 would be what year? Or what number? If one was January 49, 49, so I want to do Y1 of 49.
Why would it be,
Ooh. Is it 49?
why would it be the same temperature as before? If it was that.
It is, but it might not perfectly sit in the right place. Do you understand what I'm saying? Like, it might be part of it. It might not, how do I say this? Depending on the data points, it might not perfectly fit because it's going to be warped a little bit. We want this model to repeat exactly every 12, right?
Yeah.
Is the model that it generated necessarily going to do that? No, it might not. The period might not be exactly 12.
Oh. Oh.
You understand what I'm saying? You understand what I'm saying?
Wait,
So even by this model, it seems as though something's a little off. The point is, yeah. So what are you saying?
I think you can find it.
Okay, I can look at that in a second. I'll problem shoot specific calculators in a second. Let's talk about this for a second. Why might this be a little high? Might be too far out in the future. The model might not hold, but the point is, what model are we definitely going to have to go with for temperature modeling? Probably sine waves in this model. Probably. If we want to do a long-term projection, temperature oscillates, correct? Now, what do you know already about what do you know about modeling temperature? Anything? Okay, we might use what I already told you.
Isolate model.
In general, I want general thoughts on modeling, making temperature models, climate models. What do you know about climate models? We want it to be period of 12. Okay, new stuff that I haven't already said out loud. Let's think about this in terms of your experience in the world and your interactions with the topic of climate models. What do you know about it?
You're gonna get a
Could get consistent models. Yes, that's true. More generally speaking, though, when you hear about climate modeling, what can you tell me about it? Let's make some general statements about climate modeling. No, not conclusions about where the climate is headed. I'm talking about the science of climate modeling. Okay, I'll give you a really big hint. Is it easy or hard? It's really, really hard to do. What else? Politically, what can you tell me about it? Not everyone agrees. Why don't people agree? Why is it hard? Okay, can someone tell me one reason it's hard to model climate?
Because
It's always changing.
One at a time. Use a hand here. What do you think?
It's always changing.
It's always changing, sure. What else?
Well, climate itself, throughout the world, is not consistent.
That's true. But why is... Okay, great. It's not consistent. It changes. A lot of things change. Can you tell me why specifically climate is hard to model? Yeah.
is it because it's periodic?
Nope. It could be, but that's not what I'm trying to get at. That's a good guess. What do you think?
It's uncontrollable.
It's uncontrollable? Or so people believe. Yeah.
You can use different data
Ah, data. What can you tell me about climate data?
that it depends on who you ask.
Yeah. Many sources, and they're contested all the time. So if you contest the source data, does that allow you to contest any conclusions that are based on that data? If the data is bad, what does that mean? Everything else that comes from it is... You might have the proper methodology, but if you start with poor data, it goes away. Why else is this really hard to do? What makes modeling a situation difficult? What's one thing that can make it difficult? When you were looking around for data sets, you ran into problems. Even if you found the data set, what might be a problem? Yes, and it might not be the right data for what reason?
Probably won't find data for all of the world because just for one region.
Yeah, that's true. Might not find global data. I'll just give it to you guys. There are many, many, many variables. Do you know what one of the primary jobs the most powerful computers in the world work at? Can you give me a verb in there? Modeling, yeah. Some of the most powerful computers in the world spend the majority of their time doing what? Modeling climate. Why would you want to model climate? Why?
Predict
Make predictions, specifically like what? Yeah, like short term and what? Long-term predictions about what? What specifically about climate? Just doesn't mean temperature. What else? What else? What? But not just temperature. Ah, what did you say right there? Crisis events. Sure. Events like what? Earthquakes. What else? Hurricanes. Exactly. If we could predict these crisis events, would that be slightly helpful? Right now, how good are we at it? Right now, we aren't very good at predicting weather. Not at all.
Is it predictable?
Not very much. We're pretty good at very short-term predictions, but not very good. I mean, do the weather reports get snowfall wrong all the time? Sure. The base thing is here. I'm going to put this. There are many, 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 many variables. Many, many, many variables. Okay. Let's pause for a sec.
Do we need to graph it on the paper?
Absolutely.
Oh, graph it.
You must use some graphics to support your conclusions. Any other questions?
This is going to be on the notes, right?
This is the notes, yes. It's being recorded right now. Hi, Hanley. Hi! Everybody say hi to Hanley. 1, 2, 3. Hi, Hanley. There we go. You're in the record now.
Really?
Yeah. Other questions? What have we covered so far?
Mathematical modeling.
Yeah.
Models,
Polynomial models, models of power function, rational function, trig models. There's one topic there we haven't covered.
Rational.
That's what's coming up next, everybody. That's what's coming up next.
But why did we skip it?
The order was a little better. I wanted to cover trig models before we did it. Trig models kind of work better in that order. I decided to change it up a little bit. So that's what's coming up. Do you understand what your homework is tonight?
Yeah.
Okay, hold on to this. So if I asked you, quiet, if I asked you this question, if I gave you a nice scatter plot that looked like this.
Huh. Awesome.
And let's just say each of these points right here, it's a full scale. 1, 2, 3, 4, so that's 5, 6, 7, 8, 9, 10. And this is 1, 2, 3, 4, 5. If I said model with a quadratic, what's your first step? What do you want to do first? Someone tell me what the first step is. You do not know. I just dotted them. So this is literally what you have. Yeah, in this case, what are you going to draw? Draw a curve of best fit. What did I just tell you the model is? Quadratic model. So what shape is that? Parabola. So let's draw it. Let's draw that. That looks pretty good. What's next? I want to come up with a model, so what are we trying to determine?
The equation.
We want the equation.
Bars.
You do not have your calculator. Shh, what? Y-intercept? One thing you could look at is the y-intercept.
Vertex.
Nope, I don't like looking at the y-intercept. That could be useful, but I don't want to look at it. What's more interesting for me?
Vertex.
Vertex? Yes. So let's estimate this vertex. What do we think this vertex is?
-2, 5, -2.
2.2. Let's say that. What else do you need? What else should you do? Okay, we have the vertex. What else? Those are I want you to focus on those. Exactly. The zeros. Absolutely. So let's look at those zeros here. If we look at these zeros, we have a point right there, and we have a point right there. What does it look like that zero is? Looks like that one's 2, 0. And what is that one?
8.5.
Let's say 8.50. So we have our vertex we think is 5, negative 2.2, and we have 2, 0 and 8.50. Now, just because we estimated it doesn't mean this is possible, these estimates. Meaning, is there definitely a parabola with this vertex and these two intercepts? Not necessarily. You can definitely have a vertex in one of these points, but maybe not the other, depending on your estimate. So you have to be careful. Don't break your model. So how do we go about generating a equation from this data? Which one? Not the derivative. We haven't done calculus yet. Nope. How do we what form is the formula going to be in? Someone tell me, what form is it going to be in? No, that is for finding zeros. Can someone tell me the general form of quadratics? Here's one of them. We could use that. Absolutely. What else could we use?
The vertex form.
Vertex form. Vertex form. Vertex form. So what's the vertex form? A times
X minus X squared K plus K.
Let's look at this one first. Let's look at vertex form. Do we have an estimated vertex?
Yep.
Yeah.
So what would our equation be so far? Someone raise their hand and tell me. What is the equation so far? Hanley, yep. A times what?
A times X minus 5.
Yes.
Square plus negative 2.2.
So minus what?
Minus 2.2.
So to estimate this, to finish this, what value do we need to know? What's left?
Okay.
A. We need A. How do we find A?
Use use any
Other point.
Yeah.
Exactly. Now what's our nice point that we have that we really like? Let's use 2, 0. So when y is 0, x is
2.
So 0 is equal to 9a minus 2.2. So what's a equal to? 2.2 over 9. So what's our equation based on this method? Y equals over times x minus. So that's using the vertex method. Absolutely. That's great. Now hold on, wait. Hold on. Did we just generate a quadratic with the vertex and one other point? Yes. We didn't use the zeros, right? So are we guaranteed to go through 8.5? No. Hopefully we'll go through somewhere around there, or our model might be a little far off. But let's say we wanted to start. We either could start with the vertex or start with the zeros. Can someone tell me how we could start if we were going to start with these zeros? If these were the zeros right here, let's say we estimated the zeros. Let's say we had really great zeros. We're really sure of these zeros. If we started with those zeros, can someone give me a place to start? If 2 is a 0, what does it mean a factor has to be? Okay, ready everybody? Let's just say I gave you an example of this. X squared plus 5x plus 6. Factor that for me. Someone raise their hand and tell me what the factored form of that is. Raise your hand. Okay, no, you're done because you spoke. Yes. Times plus 2. We factored it. That tells us the zeros. What are the zeros? Negative 3 and negative 2. So if these are zeros, if those are zeros, this is a factor, and this is a factor of the original polynomial. So my question to you is, if these are zeros, what are the factors? Okay, here are the zeros. Here are the factors. If negative 3, okay, can someone tell, there's a moment right there. If 2, what are the factors? Yep.
X minus 2.
Yep. X. Yes, exactly. If 2 is a 0, what has to be a factor? X minus 2. If 8.5 is a 0, what has to be a factor? X minus 8.5. Oh, we're not quite done yet, though, because what's in front of this? We have this right now. Y equals x minus 2 times x minus 8.5, right? But what's out front? Is that a quadratic?
Yeah.
Yes, that is a quadratic, but what could be out front? there could be an A value out front. How do we figure out what that A value is? Plug in another point. Do we have another point?
Yes.
We had that other point, 5, 2.2. Now, we might be the vertex. It might be really close to the vertex. Either way, is that another point? So what do we have here? Hold on. 2.2 equals 5 times, A times what? 3 times what? A equals 3 times, oh, this is negative 2.2, sorry. 3 times what?
Negative 3.5.
0.5, right? So in this case, what did we say A was? Negative 2.2 over 3 times negative 3.5, which is 2.2 over 3 times 3.5. Is that pretty close to what we got before?
Yeah.
That's very close to what we got before. So your homework, listen everybody, your homework is listed above. And watch the video I post on YouTube called Rational Functions. You must come in with at least 2 good questions from the video. Do you understand, everybody? Get out of here.